QTH, QRP, 88. What does it mean? Where do the terms come from? Should we use them in amateur radio? Do they violate the principle of plain language in emergency communication? We'll talk about all of this and more in this episode of KD8TTE. I've been waiting for this, episode 73. Stick around.
Black one.
Telegraphy means remote writing, to put it succinctly. It has been in use a lot longer than radio. Even in antiquity, people were able to communicate over long distances through a system of signal fires, for example. Arranged on top of hills, a system of stations, to use modern parlance, would be able to cover about 20 miles for each hop, seeing a signal, mimicking it, so that the next station at the next hill would see it and mimic it. Thus, a message would be able to traverse a long distance, even before there was a lot of what we think of today as technology. These systems were able to work by having pre-arranged messages. Fires of a particular type, of a particular number, positioned a particular way, would be able to indicate a specific message. Communicating over great distance with signals developed to include the use of flags, lights, and sounds. It's a fascinating history and might be something that we cover more deeply on this channel one day. For now, what we need to know is that in all of these cases, people with training can generate a visual or audible signal that someone else with training can see or hear to understand the meaning. As we began moving into the era of electricity and moving communications down wires or along radio circuits, we needed to improve efficiency. Telegraph operators had a code where a number could allow one operator to give instructions or to query another operator on the circuit. Perhaps the best known of these is the Western Union 92 code, published first in 1859. The code developed over time and was published widely by GM Dodge years later. Amateur radio operators still often use 73 for best regards. This is why it's 7-3 or 73, but never 7-3s or 73s, because that would mean best regardses. Stop doing it, please. We also have 88 for hugs and kisses, and sometimes we'll see a newer variation, 161, which is 73 plus 88. The need for brevity in text led to the development of the Phillips Code, first published in 1879. The code, developed by journalist and telegrapher Walter Phillips, would allow news stories to be sent by telegraph more quickly and therefore less expensively. We can see an example of a phrase from a 1910 news story. The trial of Harry K. Thaw for the murder of Stanford White on the Madison Square Roof Garden, now in progress, is 109 characters. It's approximately 22 words, which would take about a minute to transmit. Now, we could use the Phillips Code and reduce that to 50 characters, about 10 words, taking less than half the time to transmit. On the receiving side, the text would be turned back into standard text. Thus, the operators of communication circuits were not only working the equipment, but were also skilled in the process of encoding and decoding to allow for messages to traverse their circuits efficiently. Some of these abbreviations managed to escape the radio circuits and are even known today, including POTUS for President of the United States, or SCOTUS for Supreme Court of the United States. While working with wired circuits or line of sight, you can be sure that everyone in the circuit was part of the same company or team, would have the same training. As radio made it possible to interoperate and more organizations had a need for operators, standardization helped to reduce the cost of training and made it possible for stations to communicate more effectively. Thus, the development of standards and the procedure signals, prosigns. Perhaps the best known of these are the Q signals that we see sometimes in amateur radio. Pro signs are valuable. They, in theory at least, are unambiguous. They're concise. They are standardized. Now, that does not mean that we should always use them. Voicing pro signs, for example, is just silly. QSL, that's 3 syllables to mean Roger, which would be only 2 syllables. An abbreviation that's bigger than what it is you're abbreviating doesn't make a whole lot of sense. It's needless indirection. We have pro words for voice, and they are also precise and unambiguous. Use the right procedure for the mode that you are working. Voice uses pro words, and digital or CW will use pro signs. And remember that for all of this, context matters. Don't be needlessly pedantic. Now, this channel focuses more on emergency communication and post-disaster communication. Amateur radio also has social purposes. They're totally legitimate. The operation is not as tight. It's more about fun, and you can include jargon and use it differently, more loosely, being friendly. It might be a way to identify somebody else as a member of the same club, the same fraternity of radio operators that you belong to. 73 is a good example of this. Now, I say that to others. I voice it, but I never put that sort of thing inside of an agency message. That's an important distinction. Always remember your context. So now for the signals. We're going to cover 3 types. The Q signals that are in general use, largely the international Q signals. The QN signals that are specific to the National Traffic System amateur radio relay nets, and the Z signals that are used in government circuits, including in 5 megahertz in the United States and some of the NATO countries. In all cases, we're going to show examples of how to use them. It's not going to be exhaustive, but there are links down in the description below that will give you more information and the foundational resources that we're using. We can take a look at an example contact that would be in continuous wave CW that's going to be sent with Morse code, of course. What we're going to hear would be the call, CQ, repeated 3 times. It's calling for a station. And then there isn't any particular target afterwards, so this is going to be a call for any station that can hear. DE, that's the pro sign that means this is. And then the station is going to identify itself, and then we have the pro sign K. That stands for key. That means I'm done keying. It's now your turn to key. A station that answers such a call may call the calling station's call sign followed by DE. This is, identify itself, and then K, over to you. The response then comes back using all of what we've seen before, and then the text will begin. This might be the sort of thing that we see in a rag chew or a contest. GM, it's an abbreviation. Good morning. Op. Matt. Okay, this is the operator is giving his name. Sometimes people will spell out name, but op is faster to send than spelling out name, and so that's what we often see. The QTH, Bexley, Ohio, EM89MX. Well, QTH, that's the Q signal that means location. Bexley, Ohio, city and state, and then EM89MX. That's going to be, of course, the Maidenhead sub-square, the location. The response then can come back. Another greeting. Good morning, Matt. Operator here is Johnny. Location, Columbus, then we'll give the grid. Once the contact has been established, then they'll stop doing a lot of the identification back and forth. The two of them are clearly talking. So there might be a response that gives something like the weather. In this case, WX, that's abbreviation for weather. HR, here. 79F, that's 79 degrees Fahrenheit. Clouds. All right, well, what do we got after that? TNX, thanks. Fur. 4. Well, that's a lot faster to send if you are using Morse code. Dit-da-dit, dit-da-dit, fur, as opposed to for dit da 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 dit. Doesn't sound like it's a big difference, but a lot of little abbreviations like that, a lot of little optimizations can add up. And that's where we get to QSO, contact. Thanks for the contact. What follows QRU, that is the pro sign for nothing more to send to you. Followed by 73, K over to you. Response comes back, weather just the same across town, hi, hi, 73 DEW8OMR. So the message comes back, we're using the same abbreviation for weather, but we're spelling this out a little bit more. This is an example of how not all operators are going to be as terse as every other operator. And then followed by hi, hi. We know that this is generally laughter. Sometimes people wonder why that is laughter. And the answer is that in Morse code, hi, hi sounds a little bit like laughter. Did-it. That's hi, hi. It sounds a bit like laughter if you think about it. 73, best regards, DEW8OMRK. So then the response comes back. It's laughter again. Did-it. This is a KD8TTE. AR, that's the pro sign that means out. I'm finished transmitting, nothing more. In amateur radio, there are several Q signals that are common, and you'll see them very often. QSB, QSL, QSY are all examples. Abbreviations and signals are pretty loose in casual operating. On traffic nets, however, things are different. It's much more formal. The net exists for a specific purpose, and it's a lot more complicated because you've got more stations talking to one another as they're moving traffic, as opposed to everybody reporting something into net control in a dispatch style that you often see in a lot of other nets. So there is more procedure. The procedure can be more complicated, and that's the reason why we need to have the precision that comes with that formality. It's not that big of a deal, though. We were able to demonstrate in the earliest episodes on this channel reporting into a net and leaving a net using signals with Morse code as we were using CW as our mode of operation. There are many more signals in traffic nets, and the complete set is available from the ARRL in the Methods, Practices, and Guidelines document. That's really where formal operations are defined and includes direction on how to run nets properly for any ARRL field organization net, whether ARES or NTS. The ARRL Pink Card and RRI 1720 Revision 3 summarize these signals with a little guidance on how to use them. The best advice is to tune into a net and listen. Observe how they're operating. Refer to your card and to the MPG when you need to see what a signal means or to understand what they're doing. You'll be surprised at how quickly you can pick it up if you are following along diligently. We'll move on to an example from the Buckeye Net, that is an Ohio section National Traffic System net that operates in the CW mode. In the beginning, the net control operator will confirm that the frequency is clear, and that's done with the signal QRL, and using amateur procedure, it's followed by a question mark. When calling the net, there's going to be the identification of the net with the distinctive sound, dit, and then there is going to be station identification. This is KD8TTE in this example. From there, we have signals indicating what's going on. QND, this is a directed net. PSEQNZ, please 0 beat. And then QNN, the net control operator is KD8TTE. Good evening, Buckeye Net. QNA, we're going to call for specific stations in order, and we have specified exactly what we're looking for. QNA 8RN, that's the 8th region net representative. To get net control's attention, you'll send a single letter. That ensures that net control is not overwhelmed with an entire transmission. Net control needs to just hear a letter and then to respond with the same letter. That will confirm that net control is paying attention to that station. Reporting into the net will then take place, sending the net control's call sign, DE this is, giving station identification, and then a listing of any business for the net, QTC, an enumeration of the messages that will follow, or a QRU, which is the signal for nothing to send. Net control will then acknowledge, typically with R, the abbreviation, Roger, and AS, that is the prosign, wait. Well, this is great, but we do have a problem. Traffic nets are controlled primarily through QN signals that were introduced in 1939. They're incompatible with the international allocation for Q signals, though. QN is part of the allocation meant for the aeronautical service. What that means is that the QN signals that we hear on traffic nets will have completely different meanings. No one foresaw this problem as long as they were only on amateur traffic nets. Today, however, things are different. Interoperability is a much bigger deal, and we even work on the same frequency as other services on those 5 megahertz interoperability channels. So QN signals are very useful. It's where the control signals are. So what do? On the Black Swan net, we regularly operate on 5 megahertz, and we specifically train to interoperate with stations from other services. We have shares stations that report in, we have Mars stations that report in, and they are able to get their work supported by our amateur operators. Those stations from shares and Mars and other government services use Z signals in addition to the international Q signals. Z signals, they're where the control is. We don't need them all, but there are a few that, if we know, we'll be able to make good use of, and they'll do the trick of allowing for tight control with telegraphy and also in a way that will be understood by the other stations outside of amateur service. Just as ACP 125 shows procedure words, pro words, ACP 131 shows the procedure signals, pro signs, for being able to work in the net. On the Black Swan net, when using digital for control, net control will typically call the net to order by first announcing Black Swan net, this is, and then sending AS, that's the signal for wait. Then after the station has announced that this is where the net is going to be, there begins the call. ZKA means I am net control. ZKB, this net is directed, and then the calls begin. INT, agency, that's asking, is there an agency out there? There can be a response that will come back, and in the Black Swan net, they'll identify not just the station, but the agency if they are not regular, or they need to identify which agency they're with. And that'll come along with also a listing of traffic if there is any. Note the use of the Z signal, ZBO, rather than QTC. You'll also notice one of the differences is that instead of sending a single character and being acknowledged by net control, there is the whole transmission. That's because the process of getting a digital transmission started takes longer than with a CW just hitting a key. So net control is going to manage the risk of doubling by making more specific calls, so there are fewer stations that will be responding at any one time. Once the station has reported in, they'll be recognized by net control. R is an abbreviation for Roger, AS again, wait. And then the call up can begin more generally. In this case, it's asking for any station to report into the net, and doing so with the signals INT, ZKE. ZKE is reporting into the net, so putting it in the form of a question, any stations reporting into the net, that's the time for someone reporting in to transmit. Signals and codes have practical application. They're not for obscuring meaning. That is not allowed in amateur radio under 47 CFR 97.113A4. Codes are used for brevity. The signals are used for precision. So it's key to remember where you are and what you're doing. Social and recreational operation can be more loose. Formal amateur traffic nets are going to be tighter, but they're not quite so rigid as what we see in the government circuits and when other agencies are being represented. In that case, keep it tight, keep it professional as you keep it friendly. See the links below for references and more detail. Like, share, and subscribe to the channel so that you don't miss anything. This is Radio KD8TTE. 7-3.